Welcome back. So far we have completed from Kubernetes fundamentals perspective. Using imperative way, we have created a pod, and for replica set, we really don't have a imperative command using kubectl. So we used the YAML format to create it, and deployment and service also using imperative way, we have created it. So now using YAML and then kubectl, we are going to create pods, replica sets, deployments, and then services in a declarative manner using YAML. So let's go ahead and then do that now. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about YAML basics. To write Kubernetes declarative manifest, we definitely need a little bit of knowledge on YAML. So we are going to look into a few YAML basics which are required for our Kubernetes manifests. So let's go ahead and then understand what is YAML on a high level, and then move on and then implement few sample things required to understand better about YAML. So YAML is not a markup language. So YAML is used to store information about different things. So we can use YAML to define key value pairs like variables, lists, and then objects. So YAML is very similar to JSON, which is nothing but JavaScript object notation. YAML is primarily focuses on readability and then user friendliness. So YAML is designed to be clean and easy to read. So we can define YAML files with two different extensions, .yml or .yaml. Anything would work for us. Okay, so the next thing is, what are the core topics we are going to cover here? Okay, so YAML comments, and then key value pairs, dictionary or map, arrays or lists, spaces, and then document separator. So let's go ahead and then implement them now. So we'll go back to our GitHub repo, and we are in Kubernetes fundamentals GitHub repo, and we are going inside 06 YAML basics. So we are going to start with comments and then key value pairs. So in YAML, so to define comments, you are going to provide it with hash, and key value pairs you can see name colon space and then value. So key colon space and then value. Space after colon is mandatory to differentiate key and then value. So let's go ahead and then define this on YAML now, right? So here in our YAML basics, we'll simply say sample file.yml. So I try to use YML instead of YAML in all our notifications, so both are same. So we are going to define a simple key value pairs. Okay, so now we are going to say name is equal to Kalyan, and age is equal to 23, and city is equal to Hyderabad. Okay, so everywhere if you see here space, so this space is mandatory for any of these things. Okay, so to differentiate key and then value, so we need to have this space. So if you remove the space, you can see that the notation looks different, right? So have the space and it looks as a key value pair. And now we are going to use Visual Studio Code for that, and whatever you want, you can just go here and then say VS Code download, and then you will be able to download the Microsoft Visual Studio Code. And next is dictionary or map. So what is a dictionary or a map? So set of properties grouped together after an item is called dictionary or map. Okay, so now if you see here, this name, age, and then city are grouped under a property or an item named person. So now person item has these properties. So now this person is a dictionary object. Okay, so now let's define that now. So we are going to say person and like this. So if you define like this, so these are not grouped under person. If you see this one, So this is one more key value pair like it looks, so it is wrong. So now we need to select all these things and then say tab. So we need to have equal amount of spaces here, and now if you see, this is the parent and these look as child. And now under person we have these properties, name, age, and then city. So now this is dictionary. Okay, so now the next thing here is equal amount of blank spaces required for all the items under a dictionary. So we have equal amount of spaces. So one tip here is whatever you select here, okay, so if you say enter, directly it will come here in Visual Studio Code, and then if you want to write something else, you can write school, okay, ABC school, something if you want to write, you can write. So directly it will come under the same indentation level in VS Code. Okay, and another important thing here is whenever you are writing YAML in VS Code, so if you want to give these indentations, you can say tab, and then it gives us 2 spaces for us. So instead of typing 2 times space, so you can even say tab, tab, tab wherever you want to write. So that is one way of doing it. So now we completed the dictionary and then map. So let's understand about arrays or lists. Okay, so dash indicates an element of an array. So I have something called, for this person he has some hobbies, and list those hobbies. Okay, so listing means those are lists, right? So now we'll go here and immediately under hobbies, right? So I'm going to say tab, and I'm going to say cooking and cycling. So like this. Okay, so like this you can write those things. Now one more means like list you can define this way, or you can define the list in the other way, which is hobbies and then square brackets, and you can say cooking comma cycling. So in any way you can write the list. So this one we are not going to use. In entire Kubernetes manifest we are going to use lists this way. So now the next thing is multiple lists. So how you are going to define multiple lists, right? So let's example, you have friends, okay, and you want to define your list of friends. Okay, so I can say name of my friend is friend 1 and his age is 23, and I have one more friend, okay, so whose name is friend 2 and whose age is 22, and I have one more. So you can, like this you can keep writing the lists. Okay, so multiple lists. Okay, multiple lists. So that's about multiple lists, whatever we are going to define. So now you can consider this as one document, this person document as one document. So what next? Okay, so you want to write one more document in the sample file. Okay, so in the sample file YAML I need to write one more document. I really don't want to create one more file here saying sample 2.yml, and then I really don't want to write it here. I want to write everything in a single file. So for that what I can do, right? So there will be something called document separator in YAML. So I can say this one, and then now I can write one more file here. Okay, so I can copy my sample pod template and then paste it here. Now if you see, so this is a separate document of YAML, and this is separate document, and then it is separated using, okay, document separator, right? YAML document separator. That's the thing. So if you see here, this pod template and all these things, we'll move on with next steps of live template writing, and there also you will understand in detail. But you can see here, you can define, you can come from top. So API version is a string, and then we have v1 value, and then kind is pod and it's a string, and metadata is a dictionary, and you have name and then labels. Under labels you can define multiple values here. Okay, so tier is equal to Frontend, etc. So now this is one more dictionary. Okay, and under root element spec you have containers, and on containers you can define multiple things. Okay, so here it is one more time, you can say this as list, and under containers this is one container. If you want to define one more container, so you can say name and container is my app2, and then you can write one more image here, right? So I can say, where is this? So I can even write here image is equal to abc slash something stack simplify slash cube nginx 2.0.0. and if you want to define ports one more time for this respective container, then you can even define those things. Okay, and then you can define container port and all the information you can define. So like this you can keep writing whatever you want in the format it is required in YAML. So the core things involved around the YAML is comments, key value pairs, dictionary or map, array list, spaces, and then document separator. These things will be sufficient for writing our Kubernetes manifest. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to write pods definition using YAML. So we are going to go to 07 pods with YAML. So we are going to do this in 3 steps. One is we are going to understand about the YAML top level definitions, and then we are going to create a simple pod definition using YAML, and then to test whatever the pod we have created, we are also going to create a NodePort service using YAML. So let's go ahead and then do that now. So if you go inside the kube manifest, you will have 3 files present here, which is kube base definition, pod definition, and then pod NodePort service. So the pod definition and pod NodePort service are going to be empty. So we are going to write them now. Okay, so let's go to kube base definition. So I'll take you to my Visual Studio Code, and if we go to the kube manifest, and inside that you can find kube base definition.yaml, right? So if you see here in Kubernetes, the 4 top level YAML items are API version, kind, metadata, and then spec. So let's see one after the other. So in Kubernetes, everything is nothing but objects. So the core objects what we are discussing now is pods, replica sets, deployments, services, and many more we can add, right? So if you see, we'll start with the kind. So the kind is nothing but the K8s objects, which is nothing but Kubernetes objects, which is nothing but we can define our pod here or replica set or whatever is the respective object. For that, whatever the YAML definition we are writing, that respective Kubernetes object will be defined here, and its equivalent API version we are going to define here. Example, if it is v1 or whatever it is, right? So how we are going to know what is the API version for this respective Kubernetes version, or maximum it is not going to change for most of the time, but here and there new changes comes into these objects, and then this API version keeps changing, not very regularly, but here and there sometimes. Okay, so for that purpose, always if you want to go and then refer the latest documentation, so we can go here, and if you go here, so you can find here. So this is the pod v1 core for v1.18. what is the definition? So let me open it here, and you can see here pod v1 core. This is the API definition. So you can see the version is v1, so which means we can define our version as v1, and then kind is pod, which is nothing but pod, right? So now if you want an example of the pod, you can even see here, right? So now the most important thing here is whatever we are going to try to do here is we are just going to create a simple pod and then expose it as a service. But what Kubernetes recommends is never ever go and then directly create a pod. So always a pod need to be created using a controller like deployment controller or job controller or stateful set controller. Okay, so this is just for our testing and then understanding about how to create a YAML definition for pod. So we are creating the definition and then we are creating the pod, but it is recommended always to create it using respective controllers. So let's come back here, and so let me remove this whatever we have created here, and now let's copy this, right? So this we are saying these 4 are the top level objects. One is API version, kind, metadata, and then spec. So what does metadata mean, right? So you are creating a object of type pod and its name, right? The pod name you can define here. Okay, so it can be my app pod, something like that, right? And you can even define additional labels here. Okay, So label can be app is equal to my app pod, something, whatever you want. Okay, so but the core thing primarily is two things which it will have primarily is name and then labels, and under labels you can again define your key value pairs, whatever you want. Okay, so but name is always required for any of the Kubernetes object whatever we create, right? So in the metadata, the one thing important is name and the other is labels. So later when we are doing the advanced stuff, we will even defining the namespaces and all those things, but core is name and then labels will be always a mandatory thing which we need to fill when we are defining it. Okay, so in such a way that which will be useful for us in the long term, or we can make it as a best practice to ensure that in metadata name and then labels we are going to definitely use it. And finally, specification or spec. So spec is nothing but our respective Kubernetes objects specification, whatever we are going to define. So the core content what we are going to define. So let's go and then remove this and then take this and then go to our pod definition here, right? And copy in the pod definition. Okay, so now we have seen that for our pod the version is v1, so API version :space v1, and the kind is going to be pod, and the metadata, under metadata we already know that name we are going to define, and we are going to say my app pod is my pod name. And labels, right? So when we have multiple number of pods and then multiple objects in Kubernetes, if we want to filter about for this respective application what is my set of pods or set of services, all those things, labels will be very helpful in the long term. So always it is good to define at least one label for our application, right? So again, labels is going to be a dictionary object. So if you see here, metadata is a dictionary object, and if you see here, on that we have defined name and then labels, and under labels again we can define multiple key value pairs. Example, app is equal to my app, and I can say tier is equal to Frontend. So like this, how many labels you want, whatever you feel like in future you can use it for filtering or whatever the basis, so you can keep defining those things. But for now I will leave it as very simple. Name is equal to my app pod and labels is equal to app : my app. Okay, so now the specification of our core pod, right? So every pod, what it does, okay, it usually runs a container. So if it need to run a container, it need the container image information, right? So it will have a object named containers here, item named containers. Okay, and this containers is a list. If you see here, I can say this as a, so I'm just dictionary. Okay, and again this is one more dictionary, right? So in YAML terms I am defining these things. Okay, so if you see, this is a string, right? And again this is a string, right? So containers is a list, which means I can define a list of objects here, right? So why? Because in any pod we can run multiple containers. We have already discussed about multi-pod applications, right? So we can define multiple containers inside a single pod. That's the reason under containers you can define multiple containers. Due to that you will get this list object as the containers. Okay, so and I'll say my container name as my app, and I will define its image now. Okay, so I can say stack simplify slash 1.0.0. so this is a simple Nginx image I have built and put it in my Docker Hub, so we are going to use it. So and under this respective means like this is a list, and then if you want to define one more container you can again define with name, right? So my app backend or something, right? And its image you can define here, and if you want you can define its container ports and all those things. So we'll define additionally ports for this container. Okay, and the container port is going to be 80, right? So I'm going to remove the other container. We are just going to do it with simple one container in a pod. So 99% cases we are going to have one-to-one relation with our pods. So that is pod to container. So we'll also follow the same standard here. Okay, so this is my pod definition. So in our next lecture, we'll focus on creating the NodePort service. But for now, we'll go ahead and then create this pod and then verify it. Okay, so let's go back to our browser, and now we have created the pod, and then let's go ahead and then create the pod definition in our Kubernetes cluster, right? So we are in the Kubernetes fundamentals folder. So we'll go into 07 pods with YAML, and we'll go inside kube manifest, and then you can find the 02 pod definition whatever we have created. So you can even see what we have created, right? So now we can go ahead and then run it, right? Kubectl create -02 pod definition.yaml, right? It is getting created. Okay, so now my pod got created. So kubectl get pods, and the pod is running, right? So in our next lecture, we'll go ahead and then create the NodePort service, and then we will test it. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. Let's go ahead and then create a NodePort service to access the pod whatever we have created using YAML definition, right? So let's go to our Visual Studio Code, and this is the 02 pod definition whatever we have created. And let's again take our API version base and then put it in 03 pod NodePort service. So now let's see what is the kind we are going to create is service and its API version, right? So let's go here and then take the documentation reference. So I can go back and put it in new tab. Okay, so this is the service pod API object reference. Okay, so let it open. So we can see the version we are going to use is v1 and the kind is service. Okay, so I will say v1, and now let's define the metadata. So metadata is going to be the name of my service. So my app pod related NodePort service we are creating, right? So nothing but we are creating the name of the service here. Okay, so and now if you want, we can even define labels for our service if you want to. Okay, so app is equal to my app. So this is optional for services, but if you want to create, we can create. Okay, so if you want to filter our services, means like we have created multiple services for a specific set of applications, and then if you want to filter them using the labels, all those services, we can still define our labels for our service. Okay, so and now the next thing is spec. In spec for a NodePort service, the type of the service we are going to do, which is nothing but NodePort, right? What happened? Yeah. And the next is, so we'll have something called selector, and one more will be there, ports. In service, these are the high level objects, type, selector, and then ports. So the selector is nothing but, so we need to load balance the traffic across pods using these labels and selectors whatever we have defined here. So if you see here in the 02 pod definition, our pod label is going to be app:my app, right? So if you define this in this, means like if you go ahead and then define that respective label here, the same label, so what it states means is load balance the traffic coming to the service across pods matching this label selector. So whatever the traffic coming to the service, if we need to route the traffic to that respective pod, this service is going to identify this pod based on this label app:my app. So this is the key value pair. So based on this selector only, it is going to send the traffic. So whatever is defined in the selector, the labels defined in the selector, only to those pods it is going to send the traffic on a very high level. So let's also define the pods. So we have also seen this, the name of the ports we are going to define is HTTP, and this is name is optional thing. Okay, if you want, you can define, and I'm going to say my service port is going to be 80, and the target port. Target port is nothing but my backend application port, which is nothing but my pod respective container port. Okay, and one more thing we can do here is NodePort. So if you want, means like whenever we have created a NodePort service using imperative commands, we really don't have an option to define the NodePort specific port. Okay, but when you come to the YAML definitions, you get that advantage to define it. So let's go ahead and then define that. So I'm going to use the port as 31231. So you can say this as node port, and this as container port, and this as service port. Okay, so like this you can define all the stuff here in your service. So if you see on a very high level in service, the core thing here is this labels is optional. If you want, you can have it or you can remove it. If you are getting confused with selector and then that label, just remove it. Okay, so in metadata, the name is the core thing, and you have defined the name as my app pod node port service. And in spec, three things are important: type, selector, and then ports. And then type is node port you have defined. So if you are using the load balancer service, you are going to say load balancer, right? Or if you are defining the external name service, you are going to say external name. Or if you are going to define the ClusterIP service, you can even say ClusterIP. But ClusterIP is the default service it creates. You really don't need to define the type there. Okay, so that's about the type node port. And selector and then ports. You will also have selector and then ports. Ports we have defined here. Selector is nothing but whatever you define the label inside the selector, right? So if that label matches with the pod's respective label, then the traffic will be sent to those respective pods, or traffic will be distributed to those respective pods whose labels match with the selector value present in a service. So that's about it. So let's go ahead and then create this service now. Okay, so kubectl create -f and 03 pod node port service. Kubectl get svc. Our service got created. So let's go ahead and then access this now. So I'll say get nodes -o void. Right, so I can take any of the external IP here. I can go to browser and 31231, right? So welcome to Stack Simplify Kubernetes Fundamentals Demo Application V1. We have up and running. So we have successfully created the pod definition and also the node port service using the YAML. So in our next lecture, we'll focus on ReplicaSets. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create the definition, YAML definition for our ReplicaSets. So this is nothing but 08 ReplicaSets. So let's go here, and as a step 1, we are going to create the ReplicaSet definition, and then as a step 2, we are going to create ReplicaSet and then verify it. And as a step 3, we are going to create the node port service and then access it via browser and then test it, right? So let's go to our Visual Studio Code. And if you see here, 01 is the kube based definition, which will have API version, kind, metadata, and then spec. So let me copy this, go to our 02 ReplicaSet definition, which is empty. I copied these things, and then let's move on to find the API version by referring our documentation here. Okay, so Kubernetes API reference doc for ReplicaSet is v1 apps. Okay, so which is nothing but group is apps and then version is v1. So let's make it as apps/v1. Okay, so if it is core, we really don't need to mention it is core. Just if you type v1, it is good. But if it is apps, then we can say apps/v1. And the kind is going to be ReplicaSet. We can see it here. So now one important thing here is 90% of the cases or many cases, what we know, always a ReplicaSet will get created or triggered by creating a deployment. So which means like 99.99% we try to create a deployment and automatically a ReplicaSet gets created. But why we are learning first ReplicaSet and then moving to deployment is both are same. It's not a different thing. But if we change this to deployment, the same thing, entire definition, whatever we are going to create now, is going to match with the replica set. And in addition to replica set, we can keep adding more and more features under the spec when you add it as a deployment. Okay, but when it is a replica set, it is only a few things you can add here. But let's learn few things now and then extend it to become a deployment in our next lectures. Okay, always a deployment is a superset of the replica set, or you can say that replica set is a small subset of the deployment features. Okay, so now let's go to metadata. In metadata, we already know enter and then tab and then name, right? So this is a dictionary. So we are going to say name is going to be whatever we want. Okay, so my app to RS is nothing but replica set. Okay, so and now let's start with the spec in our replica set. Okay, so we'll have three things here to discuss. So one is replicas. Okay, so second is selector, and third is template. Okay, so now replicas are going to be nothing but how many replicas? Again, these are spec is a dictionary object, and then you have three types of properties under it: replicas, selector, and then template. Okay, so let's start with replicas. So we need 3 pods to be created using this replica set. So that type of definition you can provide here for the replicas. And now the selector. Selector will have something called match labels. Okay, so what does this mean is like, what is your pod definition, how I need to identify your pod definition label, and then have the same thing here. Means like whatever we define the label for our pod, the same thing need to be defined here, so that replica set will identify this is my pod definition, and that respective pod definition need to be ensured that it scales accordingly, or it need to be increased or decreased, everything. Means like replica set will identify your respective pod based on the label you have identified in the pod, and then the same label if you mention in the match labels. Okay, so let's not define anything here. Let's move to the template first. Okay, so template is nothing but your entire pod definition copy should be present under the template. So you already know that we have defined a pod definition in our respective pods with YAML. Okay, so let me copy, means like let me open it in a parallel window. So how to open here is like let's catch control and then right click and open to the side. Okay, and let's make this simple. So now you have your pod definition here. So the entire pod definition from metadata. Okay, so kind and API version is not required from here. Okay, so from metadata to end, whatever is there, that is your pod definition, comes under your template section of your replica set. So go to the starting and then paste it. So is it aligned? So now let me close this pod definition. We really don't need, right? We copied it. Okay, so now it doesn't look like aligned. So why? Because it came at the root element, but ideally it should be under template as a child element. Okay, so what I'll say is select, and one tab, it came directly equivalent to template. So I'll again type tab one more time, so that now under template metadata is a child element, and it has the pod name as my app 2 pod. So we are checking for 2, right? So in the labels, I'll say app is equal to my app 2. Okay, and spec containers, and then container name my app 2 container, or whatever you want to put it here, that is fine. Okay, so that's all. Now this is the template section. So now we need to discuss about match labels, means like selector match labels for our replica set. So whatever the label we have present in our pod definition here, right? My pod label, the same thing should be present here. Okay, so I'll paste it here. So if you see now, under match labels you have my app 2, which means like the replica set will identify this as your respective pod. It need to scale up or scale down. Okay, so this pod. Okay, so one more change we will do here is this one. Okay, so earlier for the pods with YAML we have done 1.0.0. So now what we'll do is like we'll use 2.0.0. So now your tag is app2. This will not be in confusion with the existing my app pod, whatever you have created as a single pod. Okay, so you will not have any issues related to that. Okay, so now let's go ahead and then create this pod and then test it. Okay, so now we'll go here, and then now we are going to create our pod. Okay, so let's go back here, and I should be in the section 08 replica sets with YAML cube manifest. I am inside that. So I'll say kubectl apply -f, and 02 ReplicaSet definition.yaml. So if any issues, it is going to throw an error for us. It didn't throw any error. So get rs, it looks good. Okay, so let's wait for the response to come back. So all are running, current and ready, everything is ready. kubectl get pods, and we should see the pods running. So kubectl describe pod, and then my app to pod, let's describe it. Okay, and see if it is 2.0.0 image is running here. Okay, so yeah, I downloaded and then using the 2.0.0. So now one thing we can do is, we already know ReplicaSet will ensure that always whatever the defined replicas present inside that, it is going to maintain the same number of replicas. So what we are going to do is kubectl get pods, and then we are going to delete one pod, and then automatically your replica set should recreate that pod. So it's taking time. So now my ReplicaSet related pods are running. So I'll say kubectl delete pod, and I will delete this respective pod. Okay, and its age now should be not 93 seconds. Okay, so it should be lesser than that once ReplicaSet creates it. Let's cross check that now after the deletion is completed. So one more time, kubectl get pods. So I got a timeout error, we can ignore that. So now if you see here, these two parts are with the age of 2 minutes, but whatever we have deleted, it automatically recreated, ReplicaSet recreated, and it is 34 seconds. Okay, so in our next lecture, we'll go ahead and then create the NodePort service for this ReplicaSet and ensure that we access it via browser, and then in browser we get the v2 version of our application. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create a NodePort service for our ReplicaSet and then test it. Okay, so let's go back to our Visual Studio Code and go to our cube base definition, and then copy it in our ReplicaSet NodePort service. As we know, for our type of service we are going to create is service, and its version is v1, and the name of the service is ReplicaSet NodePort service. And for any service, the following three are the high level things, which is nothing but type, selector, and ports, right? So now let's start with the type, the NodePort service we are going to create. So let's mark it as NodePort, and let's complete ports before going to selector. Okay, so now ports, we are going to have a ports now, so which is list of ports. So now it is going to be name is HTTP and my port name. So this is the port name, and it is going to be 80, and we are going to define our target port, which is our container port is 80, and node port, which is nothing but on the worker node what port you want to use, you can define it. So I am going to say 31232. For our pod node port service, we used 31231. Here we are using 31232. So now the selector, again as usual, go to your ReplicaSet definition, and then this is the label you have in your pod template. So let's get that, and then to these pods it need to load balance, right? Your respective service need to load balance or send the traffic to those respective pods. Okay, so then it need to identify the pods based on a selector. Okay, so that is nothing but label selector. So it is going to be my app 2. Okay, so now your NodePort ReplicaSet service is created. So let's go ahead and then create that now. kubectl apply 03, right? And if any error, it is going to throw here any definition error or something. So ideally no error. So get svc, it looks good. So 31 with 31232, our ReplicaSet NodePort service got created. So we can go ahead and then say get nodes -o wide and get the public IP and then access it with 31232. So if you remember here, so we are accessing 31231 with the v1 application with a plain pod, and with the ReplicaSet we are going to say 31232. Okay, and we should have a v2 version of application. So with the plain pod we got v1, and then with ReplicaSet we got v2. Okay, so this completes the creation of replica set definition using YAML. So in our next lecture, we'll focus on deployment. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about deployments with YAML. So 09 deployments with YAML. So as we discussed earlier, so deployments are nothing but, again, deployment is nothing but a superset of replica set. So we have created a replica set in our previous lecture. So we are going to copy all those templates and then change its kind to deployment and then container image to 3.0.0 for a difference, and then change the NodePort service to 31233 for accessing it on the browser. Earlier the pod is 31231 and replica set is 31232. You can see it here. Now we'll use 31233 for deployments, and then change all the names to deployment in the sense like the file names or whatever we see wherever, right? Instead of replica set, change it to deployment, and also change the labels and selectors to my app 3. Okay, and then create the deployment NodePort service and then list and then test it. So before going there, let's cross check our API reference document. And for deployment also, it is app/v1. So just if we change the kind from replica set to deployment, mostly our things should work. Okay, so let's go to our Visual Studio Code, and this is the replica sets with YAML cube manifest folder. So let me copy it and then go to 09 deployments and then paste it, right? And I'll rename the file to deployment here, okay, instead of replica set, okay, so that we have it as a deployment reference. Okay, and for NodePort service, whatever we are going to create also, I'm going to change it to deployment. Good. So now our base setup is done. So let's go to 02 deployment definition, and the first thing is API version, it matched with our this one. Okay, so we really don't need to change anything here. Okay, so only thing is kind is going to be deployment, and the name is going to be my app 3 deployment. Okay, so now replicas are good, selector is good, and the app, which is nothing but the selector match labels, we said that we will change from my app 2 to my app 3. So let's change it. Okay, so and the template, my app 3 pod, I can say this one, name of the pod, and the labels I can say my app 3. So the most important thing is this one, the label and the match label, both should match, and the container name I can give it as my app 3. And finally we also said that we will change the image version. Okay, so for our difference to see on our browser, so I'll say 3.0.0. so this completes the deployment spec update. So we really didn't add any new tags or anything. So this is like anywhere replica set is a subset of deployment, right? So all these things should work as is without anything. So for deployments, we can keep adding more and more stuff based on like how the deployment should happen, and then like it should be in a rolling update fashion, or it should be in a recreate fashion. So update strategies with the recreate or rolling updates. So all those superset options you can keep adding to your deployment if you want to. But the base is replica set and then deployment, more or less it is going to be the same way. Okay, so now let's go to NodePort service, right? So this is good and no changes required inside that. So let's go to NodePort service, and this is going to be a deployment NodePort service. Okay, and the selector is going to be my app 3, right? And the NodePort I'm going to change is 31233. Okay, so now we have quickly completed creating the deployment definition and deployment NodePort service. So let's go ahead and then create them now. Okay, so we'll go to 09 deployments and we'll go to kube manifest, and I'll say kubectl apply -f 02 deployment definition. And if you want to also at the same time create one more, so that is nothing but 03, you can do this way. Okay, so now 2 files you have provided for kubectl to create. So it created my app 3 deployment and then deployment NodePort service. So I'll say kubectl get deploy, which is the alias, and it's up and running. So I'll say kubectl get pods. So I should have 3 more pods related to my deployment got created. I should have 2 replica sets, right? One for the replica set whatever we created and one which deployment created. Okay, and I'll also see the SVC. Okay, and it has the 31233 which is deployment NodePort service. So and we'll get the nodes -o wide, and we'll get the node IP, and with 31233 we are going to access it in browser. Okay, so next one, http://31233. okay, and we see the v3 version of application. So with pods, v1 application, it's up and running. With replica sets, v2 application up and running, and with pods we have v3 application. So now we have successfully created the pods with using the deployment, and then we have tested it using NodePort service. So in our next lecture we'll focus on services, and there, as we already seen NodePort service effectively, there we'll see ClusterIP service, and also we'll create a front-end and back-end application in services and then understand it in detail and then test it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to work on services with YAML. So if you remember, when we have done with imperative commands, which is with kubectl, we have created a backend deployment, front-end deployment, and backend ClusterIP service, and then front-end NodePort service, everything using kubectl. So now equivalent YAML files we are going to define and then do the same thing. So this is what we have implemented using imperative commands, and now using declaratively we are going to write the YAML manifest for that, means like the Kubernetes manifest, and then test it. So we are going to create a backend deployment and then backend ClusterIP service, and then we are also going to create manifests for front-end deployment and then front-end NodePort service, and then all in all we'll go ahead and then deploy and then test it. So let's go ahead and then start with writing our backend template. Okay, deployment template. So as usual, again we have 00 base definition, and backend deployment, backend ClusterIP service, front-end deployment, front-end NodePort service. So all are empty. We are going to write it now. So let's go ahead and then take our base definition, which is API version, kind, metadata, and then spec. So for deployment of our Kubernetes object is deployment, and its version is going to be apps v1, and in metadata we are going to say name and then labels, 2 things, right? So my deployment name, I'm going to say it as backend REST app. Okay, and labels, I'm going to say app, and also I'm going to say tier. I'm going to say backend, right? And app I can say backend REST app. And now in the deployment specification, so we have something called replicas, and we'll have selector, and we'll have template. 3 things primarily, right? So replicas, I'll say 2 or 3 replicas, whatever we want, and in selector we'll have something called match labels, and whatever we define in our labels of our respective pod template, the same thing we need to provide here. So I'll say it as backend REST app. And now in the pod template, right? So what are important things here? So we will have something called metadata and pod specification. Okay, 2 things which are on a high level, right? So now in metadata I'll have, as usual, labels, and in labels I'll define backend REST app, and if you want we can even define the tier, right? So that's all. And now this is my container specification, right? So I'll say containers, and I'll have the name of the container, which is backend REST app, and I'll have the image, right? So image I can get it from my Docker Hub. So let's go to Docker Hub, and if you see here, there should be something with hello world, right? So this is the one. So let me copy till here, and then 1.0.0. And this is a Spring Boot REST application. So it is going to have something called 8080 port. Good. So now if you see, we have completed the deployment specification. We have quickly written it in hardly less than 2 minutes. And everywhere if you see, right, API version, kind and metadata, common stuff here. And in the specification, replicas, selectors, and then templates. And the core thing which we need to verify is the selector match labels app is equal to backend REST app should match with my pod template related label backend REST app, and which matches, we are good. So now let's go ahead and then add the NodePort service for backend, ClusterIP service for backend. Sorry. So we are going to create a backend ClusterIP service. So let's take this and then our base definition, copy here and paste it. And the kind we are going to create is service, and its version is always going to be v1 currently. And the metadata, we are going to have name and then labels, 2 things here. Okay. So let's go ahead and then define them. So name is going to be my backend service. So now this is very, very important. Okay. Why? Because if we remember in our 05 services section also, we have discussed about it. Okay. So backend service name should be my backend service, so that front-end Nginx proxy can proxy to this respective backend service accordingly. The container we have built for our front-end service means like front-end Nginx proxy with this my backend service in the proxy name. So Nginx proxy pass needs this name. Okay. So good. So now the labels, as usual, the labels are going to be app : backend REST app, and here I am going to say backend. Okay. So these labels, whatever we provide in services, ideally are not leveraged anywhere other than for labeling and then filtering. But as a standard, if we provide, that is very good option for now. Okay. In our current case, to follow the standard, we are adding it. Okay. So now for a service, there are 3 things which are important, right? So type, selector, and one more, which is nothing but ports. Okay. So now type. So for type, ClusterIP is a default service. Okay. So we really don't need to mention type here. Okay. If you don't even mention also, it is going to directly create the ClusterIP service. For NodePort or load balancer or external name, we specifically need to mention the type. So we are not mentioning it. So now selector. Selector is nothing but service selector. Means like this service to which pod it need to send the traffic. So it is based on the pod respective label. So in the backend deployment, you have the pod related label here, and it has the label backend REST app. So for that, it is going to send. So I'm going to say app is equal to backend REST app. So the next thing is ports. So let's define the name of the port is HTTP, right? And we can define list of ports here, which means this is HTTP ports, and then you can define HTTPS ports, and then some port as 8443, and then target container port as 8443, etc, etc, etc. You can define here. Okay. So but for us, we really don't have any HTTPS here, only we have HTTP port, which is 8080, and which is nothing but the ClusterIP service port. Okay. So let's define that ClusterIP service port. Okay. And next is target port, so which is going to be another 8080, which is nothing but my container port. Okay. So now we really don't have anything. This is the ClusterIP service. You really don't have anything, or we don't need to define anything like NodePort here. Okay. So let me remove, and I really don't have any other ports. So this is not required. Okay. So ports is nothing but a list. Usually it is a list. So list of ports you can define. So that's about it. Okay. So now we have defined the backend ClusterIP port. So this completes the creation of backend deployment and backend ClusterIP service. So let's go to that respective folder here. So I'll go to 10 services with YAML, and I'll go to kube manifest, and then we'll go ahead and then create apply -f, and I'll create 02 backend service, and one more time I'll also give -f and then 02 over 03, right? 03, no, where is that? And 01 backend deployment. So we are creating the backend deployment and backend ClusterIP service, 01 and then 02. So let's see if we have typed anything wrong in our manifest, and then if we want to correct anything. Okay, so once it creates, we'll know. Okay, both got created, but we didn't see any issues. So we'll see kubectl get deploy, right? And it is taking a little bit of time for my cluster to respond. So my backend REST app is up and running. So I'll also say kubectl get pods, and my backend REST app is running. If we want to check the logs, kubectl logs -f, and one of the logs we can cross check here. So let me paste it. Okay, so started my hello world application without any issues. So we have tested our deployment. We'll also test the service, means like test in the sense verify our service. So my backend service, the ClusterIP service, got created with 8080 port. Okay, so this completes the creation of backend stuff. In our next lecture, we'll focus on creating the front end and then testing end to end. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create the front end deployment and then front end NodePort service. So let's go ahead and then complete that now. So let's go to our cube base definition, copy it, and go to our front end deployment and paste it. So now we are going to create the kind is deployment, and its version is going to be apps/v1. So now in metadata, there are two things which we need to focus. One is name and the second is labels. So name is going to be frontend Nginx app, right? It is going to be a front end app, right? So, and in labels, we are going to say app is equal to same. We can try and then put the same front end Nginx app. Okay, and tier we'll say front end. Good. So now we have completed the core section here, and now we'll focus on the specification section. Okay, so as usual, we know that for deployment we'll have replicas, selector, and template are the three high level objects under the spec. Okay, so now replicas will give 3, and in selector we'll have the match labels, and under match labels we'll provide the label as app is equal to frontend Nginx app. This is the same match label we need to provide whenever we are creating the pod specification here, right? So, and now under the template we are going to create the pod specification, and pod specification we'll have something called metadata and then spec. Two things under that. The child tags under template are metadata and then spec, right? So now in metadata, as usual, we can have name. So ideally, whatever the name we give for the pod here, it is going to take the reference from the deployment name. So ideally, we really don't need to give name here. So we'll focus on labels, and we'll have two labels here. One is app and the other is tier, and tier is going to be front end and app is going to be front end Nginx app. Good. So now the next thing is going to be specification of our container, right? So containers, we are going to have containers is a list of things, and under that we are going to have a container and then image name. Okay, so let's go ahead and then define those things. Okay, and we'll also have something called ports, and I am going to say container port is going to be 80, and name of my container is going to be frontend Nginx app, and the image I am going to bring that from my GitHub repo, my Docker Hub repo. Okay, so let me go to my stack simplify here, right? So where is this? Yeah, repositories, and let's go to kube frontend Nginx. Okay, so this will have the my backend service as the proxy. Okay, so let me copy this till here and I'll paste it, colon, 1.0.0, right? So this completes the deployment creation, and now we'll go ahead and then create the front-end NodePort service. So as usual, go ahead and then copy the base definition here. So let's define the service. Kind is service and the version is v1, and metadata will have name and then labels, and in name we'll say front-end Nginx app NodePort service, and labels I'll define it as front-end Nginx app. Okay, so let me remove this, and tier I'm going to say this is a front-end tier, right? Front-end. Okay, and now in specifications we'll have three things here. Okay, type, selector, and then ports. Okay, so type we are going to define it as a NodePort service. That is good. And selector, which is nothing but to which pod it need to send the traffic to from the service. So we'll go to here and then find the pod specific label here. App is equal to, sometimes we do the typos, so always go and then get from that respective pod template. Okay, so it is always good to do that way. Okay, and then in ports we'll have HTTP ports here, and I'll say port is nothing but ClusterIP service port, and target container port, which is going to be 80, and node port. So till now our demos 3.1, 2.3.1, 2.3.2, 2.3.3 over, and we'll use 3.1, 2.3.4 for us. Okay, if you don't define, all automatically cluster will provide the dynamic IP here in the respective range. Okay, so we are going to define it 3.1, 2.3.4. So this completes the creation of service 2. So let's go back to our command line and then create those things. Okay, kubectl apply -f and 03, and then -f. 03 is deployment, and 04 is front-end NodePort service. So let's see if it creates, and if not, any issues. Okay, so it created the deployment, kubectl get pods. So we'll see what are the pods it's going to create. So it's created 3 front-end pods, no issues. Okay, so I'll say kubectl get svc, and our front-end Nginx app NodePort service also up and running. So now we need to get our nodes public IP and then access it in browser. Copy any of the nodes public IP here. So I can copy this one or this one, whatever it is, right? So I'll copy this and go to the browser, and I'll create a, so let me close this Docker Hub. So we have 1, 2, 3. Now we are going to create one more, and then I'm going to say 3, 1, 2, 3, 4, and the context of my hello world application is hello, and I got the output. So now let's clear here kubectl get pods, right? And you can see that backend REST app, and then this is the pod ID, right? So we are getting 56.4xn. Okay, so how the load balancing is happening, we can even continuously refresh and then see that. Okay, so see 4DCNS. Okay, so one more time if we refresh, it might go 56.4xn. So it is load balancing across all the pods. As soon as we refresh, we are getting different IDs here, right? So that's about it. So we have successfully completed creating our backend and front-end applications using kube manifests here, and then deployed and then tested end-to-end. Okay, so in our next lecture we are going to learn little bit about recreating the objects using kubectl apply, and then understand better about it. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to delete and recreate objects using kubectl apply. So earlier you used to use kubectl delete, and then you used to provide the resource name to delete it. But here, whatever the resource you have created or the object you have created, you will be able to directly delete by referencing those YAML files. Okay, so let's see that now. Okay, so kubectl get all will provide lots of stuff whatever we have created so far. So now we will say that, so we have 4 files here. So kubectl delete -f 01 and 02 and 03 and one more time 0-f and then 04. So all the things related to backend and frontend should go away now. Okay, so all got deleted, you can see, right? So if you say get all, so anything related to our backend and frontend should not be shown now. So if you see only the pod backend REST app getting terminated, you can see these things. Okay, so nothing related to backend and frontend will be seen after these gets terminated. Nothing, right? So now you can see deployments, only my app3 deployment. So nothing in the services also, there is nothing related to front-end and then backend. So that's about it. In the same way, if you want to create it, again you can create it directly using apply hyphen and then those values. But one more interesting thing here is, so if you have these 4 files and then creating apply and then -f01 and then -f02, again it's a long command, right? So what you can do is come out of your kube manifest and just let me go here, and I don't have anything here, so I'll say mv this file, right, 00. This is not a valid file, this is just only a definition for us, right? Paste and then paste, and then I'll say it as back up. Okay, so for our testing here. Okay, so now we have only 4 YAML files here, 1 2 3 and then 4. So let me come out of kube manifest and then I'll say kubectl apply -f and then kube manifest entire folder. So whatever the YAML files present in that folder, directly present, okay, not under the recursive folders but directly present under that folder, it is going to get created. Okay, so if I say kubectl get all, again we will be able to see the deployments and services whatever related to front end, right? Front end and back end related pods are getting created, and its services also, front end Nginx and then my backend service all got created. So like that we'll be able to create and then delete. In the same way, if you want to again delete all these things, we really don't need to give that big command here. Okay, so kubectl delete -f and kube manifest, and then it is going to delete everything. Good. Okay, so now if you see get all, nothing should be there. So these are some of the things which we can effectively use for our, see, this is getting terminated, no other services related to front end or back end. Good. So now the next thing is go back to kube manifest and then change our file back, okay, to the same value, so that whenever you are doing the course it doesn't give a different show there. Okay, so now this is completed. Good. So in our next lecture we'll go ahead with another topic. So I'll see you in the next lecture. Until then, bye bye. Thank you.